Well, we've talked about nutrients, nutrient management, clean water, lighting and atmosphere control, even touched on growth media a bit. Now, in this final chapter, it's time to put it all together and provide hydroponic gardening systems to get the best plant growth results possible. We'll talk about aeroponic systems which use minimal growth media. The plants are nourished by spraying nutrient solution directly on the plant's roots. Drip systems, both homemade and commercial, use a submersible pump in a nutrient reservoir to drip the nutrient solution on each individual plant. This small commercial drip system uses a small aquarium air pump to provide nutrient to this tomato plant. As you can see, the results of this experiment was nothing less than incredible. This subaeration system proves that plants can flourish as long as proper nutrition and a constant supply of oxygen is presented to the plant's roots. Ebb and flow systems are among the most popular hobby systems. They are very easy to maintain and generally provide exceptional results. The nutrient film technique system, or NFT, is very popular for commercial farming. The nutrient flows through the rails to feed the plant's roots. The Aeroponic gardening system is one of the most efficient methods of growing plants. The system can be designed so no growth media is required. The plants are held mechanically and their roots are exposed to an oxygen-rich environment where nutrient solution is misted or sprayed, keeping the roots damp and the plant nourished. When designing your own system, the container you choose depends mainly on the size of the system you want. This tote container served well for this small lettuce garden. We've chosen to modify a quantum system for our experiment. The nutrient container is large enough and the cover already has the right size holes. Once the sprayers are in place, a high-power, low-volume pump is installed along with a standard wire mesh irrigation filter. A filter in this type of system is very important to prevent sprayer clogging. In this instance, we are using 1-inch rock wool cubes to start the seeds and cuttings, all of which will remain in this system until harvest. An interesting relative of the aeroponic system is the efficient Aeroflow gardening system. A level of nutrient solution is established inside these growth rails, which is continuously recycled and aerated. The water flow and aeration is maintained by a pump inside this nutrient solution container. The pump forces nutrient solution through spray tubes inside both grow rails. The result is an ample supply of both nutrient and oxygen, which enhances plant growth considerably. The drip system is perhaps the most popular system for commercial farming of large plants, such as tomato and pepper plants. The drip system is a very good option for the hobbyist as well, and can be purchased as a complete system or homemade to one's own specifications. The rock wool block and slab system can be used for just about any size plant, very small to very large. In this rock wool system, the plant roots travel down through the block and through the entire slab. Both the rock wool slabs and blocks can easily be replaced after harvest. Design your system to be strong enough to support the plants and growth medium. Use only quality, easy-to-clean components. For example, these adjustable drippers are very easy to adjust for the plant size and can usually be cleaned simply by removing the cap. Use grow pots that enable roots to pass through with minimal restriction. The pumping unit for the drippers consists of a small submersible pump and a short length of 1/2 inch standard drip line. A T-fitting is inserted for each 2 drippers, and flexible tubing is connected from the T-fitting to the actual drippers. This busboy tray design proved to be much stronger and more maintenance convenient than the system previously shown. Here's that small commercial trickle system again. Note the airline tube attached to the top of the device. The air from a small aquarium pump pulses through this line to force nutrient solution up the larger tube through the drip ring. We tested this unit in our small greenhouse, growing the tomato plant you see here. The last 2 tomatoes were harvested in December, and, like all the rest, they were excellent. The Ebb Flow is probably one of the oldest designs, but remains one of the most forgiving, user-friendly systems in the industry. Forgiving in that, since the plants are surrounded by moisture-retaining growing media, there is time to repair any cause of loss of nutrient flow, and user-friendly because of its simple design and ease of maintenance. A submersible pump, made automatic by use of a timer, floods nutrient solution into the growing tray to the height of the overflow fitting. In this small ebb and flow system, a relatively low flow submersible pump can be used. The pump is attached to the flood and drain fitting by use of a flexible tube cut to the proper length. When the timer activates the pump, it forces nutrient solution up through the flood and drain fitting to flood the grow container. The nutrient level will reach the height of the overflow tube, which should be set to flood the plant containers about halfway. The pump timer should be set to allow the overflow for several minutes to help increase nutrient solution aeration. This type system can easily hold 6 5-inch by 5-inch grow pots. Large or small, the ebb and flow systems operate exactly the same. The difference, of course, is the size of the pump and the number of plants that can be grown. Mentioned in Chapter 2, but well worth repeating, the turbulent action at the flood and the overflow fittings helps increase the oxygen content of the nutrient solution. By the way, it's a worthwhile investment to purchase trays and fittings online or from your local hydroponic gardening store. Once again, turbulence is a plus in the nutrient solution tank. It increases oxygen and keeps the nutrient mixed as well. Also, adding an aquarium air pump and stone is an inexpensive, worthwhile addition. These heirloom tomato plants got a great start in this ebb and flow system. The NFT system makes a great hobby system, but is also very popular as a commercial farming system. As with most hydroponic gardening systems, the pump is located in the nutrient reservoir. With the exception of winter and tropical plants, most plants prefer a nutrient temperature of between 65 and 80 degrees Fahrenheit. A small submersible heater is added to help keep the temperature in this range. On the pump discharge line, we've added a valve and garden hose connection to make nutrient changing a bit easier. 1/2 inch standard drip irrigation line is used as a manifold, and 1/4 inch straight barbs are used to attach the flexible flow lines. The flow lines are then inserted into the grow rail end caps. Once the nutrient flow starts, it should be maintained continuously because the plants are surrounded by very little, if any, growing media. It wasn't necessary in this small system, but in NFT systems with larger capacity pumps, it may be necessary to restrict the flow. Flow control can be accomplished by using adjustable hose clamps. The nutrient solution travels down the growth rails through the plant's roots, then returns to the nutrient solution reservoir to continue the exact same journey. Subaerated systems provide perhaps the simplest hydroponic gardening method of all. This experiment consisted of a glass container filled with nutrient solution, an aquarium air pump and air stone, and a clump of 4 sweet basil plants. This is the same system 4 weeks later, which we thought was pretty amazing. There are also manufactured subaeration systems that are inexpensive and work exceptionally well. This simple unit provides for 6 separate plant containers for a practically maintenance-free herb garden. The way this system operates is by the use of 1 air pump and 2 small air stones. The air stones are configured so that the air bubbles actually circulate throughout the entire nutrient container, essentially covering all grow areas. Here's an example of what can be accomplished in this small hydroponic system. I hope we've given you the information you need to select the garden system that fits your needs. Thank you for watching this program, and good luck with your hydroponic gardening adventures.